All right, welcome back to the last lesson of trigonometry, which is entitled The Ambiguous Case. I will confess that students tend to absolutely hate the ambiguous case, which usually comes from a misunderstanding of when it arises and why it occurs. So ambiguous is just something that generally means you can have more than one possible answer and you don't know which answer is correct. So for instance, when I say x squared equals 25, x might be 5 or x might be negative 5. It's ambiguous because you don't know which one is correct. And we saw a couple lessons ago that when we are using sine of theta equals a number, there's actually more than one angle that could answer the question accurately. And this can come up in triangles. So I'm going to try and make this as painless as possible by using an analogy of how it works and then giving you some questions that are basically using this idea. So I call this the fishing problem. And if you're not somebody who likes fishing, I'm sorry, but trust me, fishing is still better than trigonometry. So hopefully you'll be okay with this. So here's the fishing problem. We're going to deal with a rod that is going to make an angle of 30 degrees with the water. So let me just draw this in on the diagram. Our rod down here makes an angle of 30 degrees with the water. Why the rod is at water level, I don't know, but it makes this easy. The rod itself is 8 feet long. And what we're going to say is that we release a certain amount of fishing line, and that fishing line, we basically pretend that we have like a lure up here and we lower it down, straight down, and we stop as soon as we touch the water. So that's why I call this case one just enough line. So we have just enough line let out that we touch the water. Okay, so how much line would that take? Well, that's actually not a hard question to solve. We have a right-angled triangle there. We know that this is 30 degrees. We know it's a right angle. We know that's 8. And we want to find out this x over here, which is how much line we need. So what I'm going to do is recognize that the x is opposite, the 8 is hypotenuse, and the sine, SOHCAHTOA says we use sine of 30 equals opposite over hypotenuse. That means 8 sine 30 equals x. And if we punch the sine of 30 times 8 into our calculator, you really quickly get out that x equals 4. Now, within the context of our question, it's 4 feet, but for the purposes of this question, 4 is just enough. If we move to the next idea, where we don't release enough line, so if we release less than 4 feet of line, our lure just won't make it down to the water. So what that means here is that we've got 30, 8, and 3, and it's impossible to make a right-angled triangle out of that. It's impossible actually to make any triangle out of that works. The only two ways I could do it, again, is to take a look at this basically being the third side of the triangle. I either need to make the 3 longer or I need to make the 30 degrees smaller. But this combination together will not possibly work. So if we do the right-angled triangle, we get just enough line. Here, we can't get enough line, so we're stuck. This, by the way, is a boring outcome. This isn't the one that we're considered or too worried about, but it is a possible outcome if I gave you a angle and side lengths of 8 and 3. By the way, I think I'll point out now that in these questions, if we have these, I'm going to draw it like it connects. But these are questions where we have the angle and then this side and then this side. So basically for the fishing problem, I'm telling you the angle that the rod is above the water, the length of the rod, and the length of the string. And most textbooks will refer to this as a side-side angle problem because that's the order they appear in, side-side angle. I prefer to refer to these as angle side-side problems because these are the ones that give you the biggest pain. Anytime you've got angle side-side, these are a pain in the ass. These are difficult because they could yield the ambiguous case, which actually means there's more than one answer. Okay, so in our first example, it was a right-angled problem. That was easy. Second one, not enough line. We can't possibly make a right-angled triangle or any triangle, so we're done there. But anytime we have angle side side, we have to check for another scenario. The other scenario, the one that's actually the hard one, is the case 3. It's where we have a little more line than we need, so more than it would be if it just dangled down. So in this case, I'm going to tell you that the angle is 30 degrees and the two sides are 8 and 5. So we knew that 4 was just enough, 3 was too little, 5 is more than what is needed, but not way more, just a little more. Now the funny thing is, if I want to keep that line straight, I could cast my line out so it actually goes out further, or my line could actually come in and this would still work. So those are really two different triangles. This one looks like this, and this one looks like this. So essentially, if the question is, you're holding your rod 30 degrees above the horizontal, your rod is 8 feet long, and there's 5 feet of line out, what's the triangle look like? There's two possible answers. And this comes down to the idea that when we solve the sine law, when we solve for sine theta equals a number, there's two possible thetas, one in quadrant 1 and one in quadrant 2, that could be the answer. Okay, so let's solve these and see what happens. By the way, we're not going to kind of solve them separately. They're going to kind of sort of solve simultaneously, but we are going to find the same thing in both. In both of these, we have two sides at an angle. What we're going to find out is, let's call this, we can call it whatever letters we want. I'll call this A, B, and C, and that would make the unknown side B. And then over here, I'll do the same thing, A, B, and C, and this would make this side length C. Now, I'm going to just erase these little arrows for a second so they don't get confusing. Here, B is this distance, so it's basically the straight down version plus a little bit, and here C is the shorter distance. It's the straight down minus a little bit. It's coming backwards towards us. So let's start by just seeing what happens. Oh, sorry. I don't know why I called that C. That should be B. These should have the same letters, just two different versions. Okay, let's look at the first one and just see if we can work something out here. First of all, I have 30 and 5. That's a angle side pair. And then the other ones here, I don't know big or little b, angle B or side B, but I do know that this is 8 and this is C. So let's see what happens if I set this up. Unknown angle C, that's the only one of those four things I don't know. So I'll do sine C divided by 8 equals sine 30 divided by 5. That means that sine C equals 8 sine 30 divided by 5. 8 times the sine of 30 divided by 5 is 0.8. And the second function, sine, is 53 degrees. So C is 53 degrees. However, I'm going to do this on the bottom just because I need a little bit extra room. 53 is one possible angle, but I do know from my cast rule that 53 degrees here, sine will also be positive in the second quadrant, which means 53 degrees here. And if I do that, that 53 is actually 180 minus 53, which is 127. So C is either 53 or 127 degrees. And as it turns out, both of those are valid. So what I'm going to do is redraw my two triangles here just to make them a little bit clearer. And I'm going to fill in the information I have for both of them. So the first one looks like this. And the second one looks like this. Now, in both of them, this is 30 degrees. This is 8 and this is 5. However, angle C, one of them is 53 and one's 127. Well, this is the acute one, so that's the 53. And that makes this one the 127 degree version. So now what I can do is find out that missing angle at the top, angle B for both triangles. I'm not going to bother writing down the math on that one. I just know that the three angles total up to 180. So in the first triangle, it's 180 minus 30 minus 53. And that gives me 97 up here. And in the second one, it's 180 minus 30 minus 127, which gives me 23 degrees up there. So in my original diagrams, this is 97 degrees. And this one here is 23 degrees. Now, the only thing I don't know is the length of B in both of them. Basically, the length, how far the bottom of the line is in the water compared to where my reel touches the water. But I can solve for both of them using sine law. So if I call this one B, if we want to be technical, I mean, you can call these B1 and B2. It doesn't matter, or you can call them something different. But either way, they're the B in each diagram. We can solve that using the sine law. B1 over sine 97 equals, again, I can choose either the 8 and the 53 or the 30 and the 5. Given the two options, I'm going to choose the 30 and the 5 because they're original information. I didn't have to solve anything special with those. So B1 over sine 97 equals 5 over sine 30. And that means B1 equals 5 sine 97 over sine 30. Throw that into the calculator. And I get 9.9-ish. 9.9 feet, I think. Either way, 9.9 is my kind of bottom value. Just 9.9. Okay, so that was for the longer of the two B's. And then this one here, the setup's almost the same. B2 over sine 23 equals, again, 5 over sine 30. B2 equals 5 sine 23 over sine 30. And that gives us 3.90 or 3.9. All right, so that's the idea, is that sometimes we can be given two triangles that have the exact same description, and we have to figure out if we're talking about one the other, or if we should solve for both. So in this case, both of the triangles are both identically described as being an 8-foot fishing rod with an angle of 30 meters above the ground has 8 foot, did I say 8 meters? 8 foot fishing rod, 30 degrees above the horizontal, has 5 feet of line out. What's the triangle? And the answer is there's actually 2 triangles that meet that criteria. All right, so that was case 3. This is the one that's the tricky one. Okay, so just to recap real quick. Case 1 is where we have just enough line. So basically, the numbers that we get form a right-angled triangle, in which case there's only one triangle. Then we get the example of the 3 numbers we get can't possibly form a triangle, the not enough line example. If there's a little extra line, we can get either possible triangle, and then this is the pain one, the one that we have to solve for both cases. And the last one is where we have too much line, and specifically where the amount of line is bigger than the length of the rod. So in this case, we still have the 30-degree angle, the 8-foot rod, and this time I said there's 10 feet of line. Now I'm going to make a little bit of a mess of my diagram for a moment, but I'm going to erase it to explain why this isn't a problem. We'll see mathematically why it's not a problem, but I want to show you logically why it's not. Before, we had one version where it came out like this, and then the other version where it came back a little bit. But here, if we're coming back with a 10 foot of line, it actually comes out over here. And then the line is behind the rod, and it's just not really the triangle we're describing anymore. So the triangle essentially is inside out at that point, because the 30 degrees is not within it. So if we have this scenario where the amount of line is too long, specifically longer than the first side, so 30 and then 30 degrees, 8 feet, and then a number bigger than 8 feet, it won't work. So if the number across from the angle is bigger than the other side, this is what will happen. The good news is you don't have to worry about it until you actually go to interpret it. So what we do with the last one is we're just going to put on some things here. I have an unknown angle up here. I have an unknown angle here, and I have an unknown length here. And I think last time we called these A, B, and C, and then this side here was B. Okay, so here we have our side angle pair. Here we have a side angle pair with one of the unknowns. So we'll solve for C first. Sine of C over 8 equals sine of 30 over 10, which means sine C equals 8 sine 30 over 10. That's 0.4. And the inverse of 0.4 is 23 point something. We'll round off to 24 degrees. Okay, so I had mentioned last time that anytime you get one of these angle sides, it could be ambiguous. So if you're not sure whether it's case 3 or 4 or 1 or 2, start this and just see what happens when you go to solve it. So we got 24 as one possible answer. But remember that 24 here. We could also get that here, which would give us an angle of 180 minus 24. 180 minus 24 is 156 degrees. However, just by observation, if C is 156 and A is 30, C and A are already over 180, and that means that this answer is not possible. So it turns out that if the second side length is long enough, we go from ambiguous back to just one case again. So then we don't have to solve 2 triangles. We've already solved for 2 of the 3 angles. We can solve for angle B. B is just 180 minus 30 minus 24. So B is 126 degrees. And we already said that the only possible answer for C is 24. And then finally, to solve for length B, B over sine 126. I can use either of the other two pairs right now, but I'm going to go back to the 30 degree and 10 because that's both original information. So 10 over sine 30. So B equals 10 sine 126 over sine 30. Which gives me 16.2-ish. And looking at that triangle, I think that makes sense. B is a pretty big angle. The two sides, the two short sides are 8 and 10, and the third side, the longest side, 16.2. The third side's never going to be bigger than the other two added together. If there was 180 degrees between them, that would stretch out into a straight line of 8 and 10. So we're nowhere getting something that's longer than 8, longer than 10, but smaller than 10 plus 8. So that seems like a perfectly valid thing. And once we have that, we have, let me just make sure here, turn these off for a sec. We have that angle, that angle, that angle, that side, that side, that side. So we have solved for everything in that triangle, and we are done. All right, so I have given you a few of the questions here. I've just given them to you without a diagram. Part of the thing is if you're given a diagram, usually you can determine which of the two triangles it might be if there are two. I just want to remind you here that the way that these are given, it's the A and the A that are the problem. So it's the size of side A versus the side of size B that matters. So here we have side A is 9 and side B is 7. 9 is longer than 7. So that's, well, I'm going to give away the first one. This is going to be case 4, where the amount of fishing line is longer than the rod. The A is bigger than B. And then for each of the others, you'll have to figure it out on your own. Again, if you're not sure, just set it up, start to solve it with the sine law, and then see what the sine law does. If it's the first case, you're just going to get one answer and find out that the answer is 90. If it's the second case, you're going to find out that the answer is impossible. It doesn't work. The third case, you'll have two answers for angle C, or in this case, I think it's angle B, depending on how I label the triangle. And if there's the second side is longer than the first, then you're going to get case 4 where there's only one triangle again. Okay, try those out. I know that this is a complicated topic for most people. All I can say is the good news is, well, I'll try to make the test as painless as possible. That's the best I can promise. Anyway, give those a shot. Reach out to me if you're having trouble with it. I'll see if I can help you out. Otherwise, that's it for unit on trigonometry. I guess the next place we'll see is the test, and then the next unit on trig functions. Good luck, and we'll see you later.